Hello students, we are going to discuss about kinetic theory of matter, means the movement of particles of a matter. We have already discussed that there are 5 states of matter. These are Bose-Einstein state, second one is solid state, third one is liquid state, fourth one is gaseous state, and fifth one is plasma state. Okay, then Bose condensate state is present at very low temperature, at minus temperature, and at nearly minus 273.15 degrees Celsius. Then the state of matter is known as Bose-Einstein state. When the temperature of any substance is minus 273.15 degrees Celsius, then this state of matter is known as Bose-Einstein state. Means when you took the matter at very low temperature, then this state will be known as Bose-Einstein state. And when any gas is present at very high temperature and particles of gas are present in ionic form, ionic and atomic form of any gas, is known as plasma state of matter. Then these both states are at, one is at very low temperature and another one is at very high temperature. So the three intermediate states are made for us. First one is solid, second one is liquid, and third one is gaseous state. These main three states are in our surrounding. We don't have Bose-Einstein state or plasma state in surrounding of us. Okay, then we are going to discuss kinetic theory of matter. Then we are going to discuss about the kinetic theory of matter. Okay, then we are going to discuss about the kinetic theory of three states of matter. One is solid state, second one is liquid state, and third one is gaseous state. You all are familiarized with these three states. Okay, in your surrounding, all these three states are present. Just like of solid state, your pen, your pencil, your book, chalk, duster, table, chair, doors, your car, these all are solid in nature. These are solid in nature. These are solid state which have fixed shape and fixed volume. And you are also familiar with liquid state. You are also familiar with liquid state, just like of water, just like of petrol, diesel, kerosene oil, thinner, etc. Alcohols, these all are liquid state. You all are familiar. You are nowadays using sanitizer. This is also the liquid state. And the chemical component, alcohol is a main component of that sanitizer. So these are liquid state, and the bottle in which it is kept, it is solid state. Third one is gaseous state, and you are also familiar with gaseous state. Clear? The most important example of gaseous state is LPG cylinder. What is the full form LPG? Liquid petroleum gas. Liquid petroleum gas. What is the means of liquid petroleum gas? When the two main components are propane and butane of LPG. When these two components are filled in cylinder at very low temperature, it converts into liquid state, and when it came out from the cylinder, it came on liquid state, yeah, or it becomes liquid, or it becomes gas, You all are familiar. If you open the regulator and the switch of gas, then you can see that the gas move in complete, the smell of gas filled in your room or home completely. It means that is a gas. So you are familiar. Air is also a best example of gaseous state. Air is also a best example of gaseous state. Okay, so there are main three states: solid gas, solid state, liquid state, and gaseous state. The example of solid are, there are many solid examples in your surrounding. There are many examples of liquid state, and there are also many examples of gaseous state: air, LPG, etc. Your perfume bottle, just like a fog, if you press it, then gas completely fulfilled your the smell of perfume completely fill in at your room. Okay, then arrangement of matter. What is the arrangement of matter? So you can see in figure, the particles of solid state are very closer or closely packed, so they can't move here and there, they just vibrate. Second one is liquid state, in which molecules can move here and there because there are some gaps and random arrangement. But in gaseous state, molecules are so far from each other, the gap between molecules are so much high. Then we are going to discuss about state of matter. Number one is solid state. What is solid? Has a fixed volume and shape. Solid has fixed volume and fixed shape. If you have a pen, then you can see that have a fixed volume. If it has total 20 ml volume, or it contains 20 ml volume, then it is always 20 ml, and the space it occupies, its shape is always fixed. Then you can say that solid state has fixed volume and fixed shape. And another one most important point, solid state cannot be compressed. Okay, because molecules are so closer with each other, so compression in solid state is a difficult task, so you can't compress solids. Next, second state is liquid state, just like of water. You all are familiar with water. You use it in your daily life. Okay, these have fixed volume. If you take 1 liter of water, you fill it in bottle, you fill it in jug, you fill it in bucket, you fill it in drum, anywhere, its volume remain only 1 liter. It doesn't contain the whole volume of container. It just contain 1 liter volume of the container, and this remaining volume is occupied by the gaseous state. You all are familiar with it. If you are not familiar, then you can make an experiment for it. You take some amount of water in glass and then fill it in bottle. Then you can see that volume of water occupy the volume of same volume occupied of the bottle. Clear? Has fixed volume but doesn't have fixed shape. But they have not fixed shape. When it was in glass, it have the shape of glass, but when it pour in bottle, it occupies the shape of bottle. Means shape is not fixed of liquid, but solid have fixed shape and fixed volume. Okay, when it pours in container, it takes the shape of container, cannot be compressed easily. Liquid also cannot be compressed easily. Okay, because there are not so larger space in between of molecules, but they can be compressed when they are converted into solid state. Clear? Third state is gaseous state. Then gases doesn't have a fixed shape or volume. Gases doesn't have fixed shape or volume. Gases doesn't have fixed shape and fixed volume. Why? An example, when gas kept in any container, it takes the shape of whole container, or it is spread in whole of the container. So what is the whole volume of gas? If you take 5 ml of gas and you put it in 5 liter of container, then what will be the volume of gas? 5 ml or 5 liter? What will be the volume of gas? 5 ml or 5 liter? Then the volume of gas will be 5 liter. The volume of gas will be 5 liter, not to 5 ml. Clear? So it doesn't have fixed shape. They take the shape of container and whole of the container. It is spread in whole of the container, and it doesn't have fixed volume. But there is very large gap. The 5 ml of gas convert into 5 liter. Then the compressibility of gas is also very high. If it convert from 5 ml to 5 liter, then you can compress it from 5 liter to 5 ml. When you compress the gas, it convert into very low volume. Clear? So gas have no fixed shape or fixed volume. They can compress very easily. Clear? So in solid, fixed shape, fixed volume, and cannot be compressed. In liquids, have fixed shape, have fixed volume, but have not fixed shape, and it take the shape of container and cannot be compressed easily, but can be compressed if you want. Gases doesn't have fixed shape, have no fixed volume, and compressed very easily. Okay, next, third heading is arrangement and movement of particles. The particles are packed closely together in an orderly manner. एक orderly manner में arrange होते हैं. The particles of solid are arranged in an orderly manner. There are strong forces between the particles. Between the particles, strong intermolecular forces are present. So they cannot move easily from here and there. The particles can only vibrate and rotate about their fixed position. They can just vibrate and can rotate at their position. Clear? This is the solid state. This is the kinetic theory of matter. Only vibrate and rotate. Second state is liquid state. Though the particles are packed closely together but not in orderly arrange. They are closely packed. Some forces are present. So some closeness in between of molecules or particles, but they are not orderly arranged. Means they are amorphous in nature. Means there is not fixed arrange. But in solid there are a fixed arrangement of particles held together by strong forces, but weaker than the forces in solid. There are also present strong forces, but these forces are weaker in comparison of solids. So some gaps in liquids are greater than in comparison of solids. The particles can vibrate, rotate, and move throughout the liquids. Particle can also vibrate, can rotate, and move throughout the liquid. If you increase the temperature, then the molecule present at the bottom came at the top of the water. Okay, so they can move from here and there in zigzag motion. They collide against each other. When they move from here and there, then they collide and change their kinetic energy. Third one is gaseous state. The particles are very far apart from each other. In gaseous state, particles are very far from each other and in random motion, and they are always in random motion. Weak forces between the particles. There are very weak forces all present in between of particles. The particles can vibrate, rotate, and move freely as they want. They can move from here and there in whole of the container. the rate of collision is greater than the rate of collision in liquid, and the rate of collision is very high in comparison of the rate of collision in liquids. So these three states, so in solid state, randomness or movement of particles is nearly negligible. In liquid, movement of particles is greater than the solid, they can move in whole of the liquid, but the gas is completely free because there is no force of attraction in between of the molecules of the gaseous particles. In liquid there are some strong forces just like of hydrogen bonding, van der Waals forces are present, and in solid intermolecular forces are very high, so intermolecular gaps are very low. In liquids intermolecular forces are less than solids, so intermolecular gaps are greater than the solids, and in gases intermolecular forces are nearly negligible, so gaps are very high and they can move freely. There is no force of attraction in between of particles. You can see also these figures. In solid there is very less gap, in liquids there is some gap and they can move here and there in whole liquid, but in gas there is so much gap in between of particles, so movement of particles is very high. Now you can see the rearrangement or rechange of the particles or states of matter. This is the rearrangement of state of matter or conversion of state of matter. How can you convert the state of matter? Liquid, solid and gaseous state, how can you convert? If you increase the temperature, then kinetic energy of particles increased. If kinetic energy increased, then movement increased. Then on increasing the temperature, you move from solid state to liquid and from liquid state to gaseous state. So on adding energy, when you add the energy, just like here, in this figure, you can see on adding energy, from you are going from solid to liquid, liquid to gas, and on removing energy, if you remove the energy, you can go from gas state to liquid state and liquid state to solid state. Then you can see in this figure, on adding the energy, randomness of particles is increasing because kinetic energy is increasing and the state is converting from solid to liquid and liquid to gas. And on removing the energy, when you cool it, when you heat any state of matter, then you go from solid to liquid and liquid to gaseous state. And on removing the energy, when you cool it, then gas to liquid and liquid to solid. Then you can see here, from solid state to liquid state, when you convert solid into liquid, it is known as melting. When you kept ice in open air, you see that ice is melted and it convert into liquid state water. And when you kept water or keep water in fridge, then you see that liquid state of water convert into solid state of water. This is known as freezing. This is known as freezing. Next, liquid to gaseous state. When you heat the liquid, it evaporates. When you heat the liquid, it evaporates at any temperature. The upper layer of liquid state has high molecular energy, so it evaporates continuously. Okay, there are 2 points. One is evaporation and second one is boiling. Evaporation occurs at each temperature, but boiling occurs at a fixed temperature. Okay, while condensation condensate of any state. So when you cool the gas, it condensate. In LPG cylinder, we condense the gas and it convert into liquid form. Okay, so liquid into gas, this is known as evaporation or boiling. Boiling is a fast process and rapid process, and at that temperature, particular temperature, whole of the liquid evaporates or vaporized. While in evaporation, the speed of vaporization is very slow. Clear? In condensation, gaseous state convert into liquid state. Next, solid to gas. Some of the substances convert into solid to gaseous state. Some of the substances in nature which directly convert from solid to gaseous state without converting in liquid state. This is known as sublimation. This is known as sublimation. When solid is heated, just like of camphor, iodine, when these substances are heated, it convert into gaseous state directly without converting in liquid state. And from gas to solid state, reverse process. This is known as resublimation or rechange of sublimized state, just like of NH4Cl, ammonium chloride. NH4Cl in solid state, when heated, it convert into NH4Cl gaseous state, and when it cooled, it convert into again solid state. Okay, so when solid state goes to gaseous state, it called sublimation, and when from solid gas state to solid state, it is known as resublimation of the state. Clear? Then molecular model. Properties, intermolecular forces. Solid, very strong. Liquid, very strong but weaker than that in solid. Intermolecular forces in solids are very high. We have already discussed. In liquid, very strong but weaker than that in solid. Gas, intermolecular forces are negligible. Intermolecular distance, about 10 to the power 9 meter molecules are closely packed. About the gap is 10 to the power minus 9 meter. Molecules are closely packed and therefore gives the solid a rigid shape. Molecules are closely packed, so they give a rigid shape. In liquid, also the gap is nearly 10 to the power minus 9 meter, near about the solid, but some greater than it. Molecules are slightly further apart than in a solid. Slightly gap larger than in a solid, and take the shape of the container which holds the liquid, and it take the shape in which it is pours. In gas, about 10 to the power minus 8 meter, it may be or greater, infinite. Molecules are very far apart and therefore free to take up any space which is available to them. They can fulfill the whole space of the container and whole shape of the container. If you put the 5 ml gas in 50 liter of the container, then the volume of the gas is 50 liter, and what is the shape of that gas? The shape of the gas is of the whole container. When it was in 5 ml container, it has the volume of 5 ml and shape of that 5 ml container. When it put in or pour in 50 liter container, it has the volume of 50 liter container. Motion in solid, vibrate about fixed position, held together by strong intermolecular forces. Liquids free to move about between clusters but confined within the containing vessel due to attractive forces between them. High speed, independent motion in random manner. So I know you all enjoyed this chapter or this topic, kinetic theory of gases and conversion of the state of matter. Okay.